Here's my tutorial on stoichiometry with beads or beans. I have chosen red beans and black beans here. Number one, I got 10 red and 10 black beans. I choose, just because I'm choosing, to say that 3 red plus 4 black makes 1 set. Here are my 10 red beans on the scale. This mass is slightly different than what it shows in number 3, but we'll work with it anyway. Here are my 10 black beans on the scale, and this mass is a little bit different than on my example paper, but it's fine. It was 5.28 grams for every 10 red. So that means it is, divided by 10, 0.528 grams for every red bean on average. My 10 black beans were 1.65 grams. Divided by the 10 beans total means that it is 0.165 grams per black bean on average. I choose to make 3 sets just because I choose to. 3 sets times 3 red per 1 set, 3 red per 1 set, means I will need 9 red beans. The grams of red needed will be the 9 red that I'm going to use times the average per red. So we're going to use this. The red cancels out, and I will need, multiply, divide, 4.75 grams of my red beans. Black beans needed, well, I can figure that out by looking at my red beans. I'm going to use 9 red beans, and it is a ratio of 4 black to 3 red. 4 red to 4 black, or 4 black to 3 red. Red cancels out. Multiply, divide. I get 12 black beans is what I will use. The grams of black beans will be, take the 12 black that I'm going to use and multiply by the average gram per bean. So 12 times this divided by 1 means I will use 1.98 grams of black bean. So what will a set weigh? This mass plus that mass put together, added up, will be 6.73 grams for every 1 set. I decided number 10 was redundant. We're going to skip it. I got my 9 red and 12 black together. I put them on the scale and I got my mass. This is slightly different, but in reality, I got this. My percent error will be big number minus small number. We're going to compare the calculation versus the reality. It doesn't matter which one is subtracted out, because really this is absolute value. So we can just do big minus small. I can just do big minus small, whichever way that goes. Divided by what reality gave me. Reality actually gave me that. So it is on the bottom of my fraction here. Subtract, divide, times 100 makes it a percentage, and I got 1.6% error. My evaluation, well, my percent error is pretty low considering that these are beans. If they were computer-controlled, manufactured bolts or nuts or something, then those should be very identical. But beans are not going to be very identical. So my percent error was low, especially considering that it's beans. So the math is a good predictor of reality, which is my point. When we do this math, we are not just making it up. We can prove it by doing real items, using real items like beans.